There will be some kind of revision right from the point one, as well as we'll finish off these intelligent agent which we have studied. So I'll just go back a little bit what we have studied in the last lecture. So this is about the types of intelligent agent. So we have a reflexive or reactive type of intelligent agent, then model based intelligent agent. You have a goal based intelligent agent, then utility based and learning agent. So up till utility based of based agents, intelligent agents we have studied. So this was the reactive agent which we have seen. So you can see the difference here. There is an environment, reactive agent, right from the sensing perception is done, and to the actuators there is a rule in front, a rule where the actual decision is taken, and then the action is taken on the environment. So this is what the reactive agent was. Then we saw this deliberative agent. So what is the difference between reactive agent and deliberative agent? So you can see that there are sensors, processing and control is there. In case of processing, we have a domain knowledge. Whereas in case of deliberative, you find that there are sensors, processing and control. Instead of rules, we have a goals here. And in processing, we have domain knowledge. Instead of that, we have internal state, evolution, and prediction. So this was the difference between reactive and deliberative agent. Then we have seen a goal-driven agent. So in case of goal-driven agent, we know that there is an sensors and then actuators. Same thing is there. The environment is there. So sensor takes the input from the environment, and the actuators takes an action on the environment. So in between, what are the things that comes into goal driven? So obviously what the world is like now. So the present state will be there. Then how the world evolves, what it will be like if I do action A, what my actions do. So accordingly, what actions I should do now according to the goal that is been set. So this what actually happens in a goal driven. So this is completely a goal based, and according to the goal, the decisions are taken. This is called as the goal driven agent. Then we'll move to the utility driven agent. So this we have also seen in the last lecture. Now what is the difference between goal driven and utility driven? So if you see the difference between goal driven and utility driven, the utility factor will come into the picture. So same thing will be there. It will be having the sensors which will sense the sensing from the environment, and then the actuators will take the action. So in between sensors and actuators, it will be having what the world is like now, that is giving the present state. Then what it will be look like when I do action A, right? So this will be the same thing. Now but the difference between the goal driven and utility driven here is that it is completely a goal based. So the main target is to reach to the goal. So however you reach it, that's different question. But in case of utility driven, the goal is based on the utility, or I could say the utility will come into the factor for taking the actions. So what will be the utility? How happy I will be in such state. So what is the state? The state is to move, reach to the final destination, and what action I should do now. And that will be given to the actuators, which will be taking an action on the environment. So this will happen from sensors to actuators. So everything in the goal driven will be similar to utility driven. Only two factors will come here, is the utility and what action I should do now. That will be also same. Only one factor will come here, is the utility. That is how happy I will be in such state. If I'm not happy in such state, it will go back. है ना? So because happy or unhappy is the word that cannot be used here technically, and henceforth the scientists or the researchers have named it as a utility. So this is completely a utility driven agent. So up till now in the last lecture, what we have seen is about goal driven, utility driven, deliberative agent, and then reactive agent. And now we'll be moving to the last agent, that is called as the learning agent, which is a full-fledged agent. If you see at the figure of these agents moving around, you can see this is the, if you see this figure, you can see that the learning agent is a full-fledged who can learn like a human. So it will be completely mimicking a human behavior. So that is what the thing which we are going to study today is, the learning agent. Now what differences do you find between the other agents and this learning agent? can be studied from this block diagram. So you can see the block diagram. If you look at the block diagram, you can have an again environment is there. So the sensors will sense the input from the environment. Then there will be actuators, so which will take action based on the decisions made on the environment to the environment. Now in between this, there is some different parameters that will be coming between sensors and actuators. So from sensor, it will be going to a critic, right? You can see that this is the sensor. It selects the best option, best action. It will go to the performance element, and then it will go to the actuators. But this will not complete here. From sensor, there will be one more input that is will be going to the critics, where there will be a performance standard will be placed, so which determines the performance. And there will be a feedback. The feedback will be given to a learning element. This learning element and the performance element will exchange the data between them. So it will be having whatever the changes are happening according to learning or according to the performance standard. These changes will be given to the performance element, and which will be acknowledged by mean of giving knowledge back to the learning element. Then this learning element, according to the goals, will make a problem generator. So from here, actually here we are having making improvements. So learning element की वजह से यहाँ पर improvements हो रहे हैं, और जैसे ये learning element problem generator को जा रहा है, it suggests exploratory action, and then it will be given to the performance element. So there will be a closed loop feedback here. So everything will be coming here at the performance element, and then the selection of the best action will be taken, and according to Lee, the action will take place. Have you got it? I'll once again explain. What will happen is that the sensors will sense the input from the environment, and the actuators is going to take the action. So this is a very common in all the agents. So sensors, actuators, and environment. Now, there is a difference between the blocks that are been present between sensors and actuators. Now here, what is happening is that the sensor is given to the performance element. Now this performance element will be requiring some kind of elements for the performance to take best action. So for that thing, these input sensors will not only given to the sensor is not only given to the performance element, but it will be given to the critics, where the performance standard is stored. So it determines the performance. The feedback is given to the learning element, where it will make an improvement. How it will make the changes happening. It will give the changes to the performance element, and as the result, the knowledge will be given to the learning element. So here the improvements will be taken, and according to the learning goals will be set. So it will suggest the exploratory action through this problem generator, which will be given to the performance element. Now the performance element will be having the input from the sensors, the input from the learning elements, and the input from the problem generator. And based on this, it will select the best action that is to be taken, that will be given to the actuators, and these actuators will take the action to the environment. So this is what the thing is happening in learning agent. So now if you look at the earlier agents, you'll come to know that in that case, what was happening was they were reactive agents. So it was rule based. Deliberative agent, it was a goal based, and goals were set. Then the goal driven, it was completely driven by the goals. Then you have utility based agents. Then what is the state of the internal state, whether it's happy or unhappy. Now here in learning agent, you'll be having the learning element. So how the learning element will come into the picture, again in between sensors and actuators. So the learning element, in coincidence with the performance element, will select which kind of action to be taken in case of learning agent, and then the actuators will implement the action that is to be taken. So this is how the learning agent works out. In many areas of AI, the preferred method, that is to build learning machines and then to teach them, is for creating state-of-art systems. Obviously, where artificial intelligence comes into the picture, at that time there will be some learning machines we have to build, and we have to teach them. So when we teach them, they actually learn. Whatever we teach, they start learning. They learn something. And that is for creating the state of art system. Ultimately, our main goal is to create the state of art system. So how that can be happen? It can happen by teaching them so that they can learn. This is what the learning agent does. The learning has another advantage. That is, it allows the agent to operate in initially unknown environment and to become more competent than its initial knowledge alone might allow. That means here two things will happen, because what happens, like human learns, these agents will also learn. So how we learn? We learn according to the environments, according to the situations. Then somebody teaches us. Accordingly, the whole knowledge is gathered, and then accordingly the actions has been taken. So the learning agent will actually operate initially on the unknown environments. See what happens if I'm a person who can adapt to the situation, adapt to the environment, it's very good. But if I'm been working in an environment where the temperature is around about 36 to 38 degrees Celsius, now suddenly I am been exposed to a temperature around about 50 degrees Celsius, like in Rajasthan, it reaches 48 to 50. Now what will happen? As a learning agent, I should be able to operate initially on these unknown environment. Now this is completely an unknown environment. So if I'm able to adapt to this unknown environment, I will become more competent as compared to what initial knowledge that is in with me. Because what will happen? Because to work on the known knowledge is somewhat different, because I'm knowing it. I'm knowing how to stay in 36 degrees Celsius. I'm knowing how to live in this temperature. But certainly if you're exposed to a temperature which is higher than that, then it has to adapt to that environment. So how it is adapting? You're learning how to stay in this environment. You're learning how to stay or survive in this temperature. And that is where this learning comes into the picture. है ना? गोल बेस्ड हो, यूटिलिटी बेस्ड हो, वो बात अलग है, मगर लर्निंग की बात अलग है. Because human learning, if a robot starts doing like a human learning, then magic will happen, and that is what is happening. So when it will start operating initially on the unknown environments, then it can become more competent as compared to working on a known environment. That is what does it mean. A learning agent can be divided into four conceptual components as shown. So you can see that there are four conceptual components. One is your performance element, the critics is there, the learning element is there, and then the problem generator is there. The most important distinction is between learning element, which is responsible for making improvements, and the performance element, which is responsible for selecting the external environment. So दो चीजें सबसे important बनती है, वो है ये learning element और तो ये है performance element. दिख रहा है यहाँ पर? These are the two blocks, right? Now the distinctive part of the learning element will be, it will keep on learning. So when it keep on learning, it will keep on improving. If we keep on improving, then what will happen? The performance element will be responsible for selecting that action, what to be taken. Because while learning, it will keep on improving, and this improvement will be given to the performance element, which will be responsible for the external action. Right. The performance element is what we have previously considered to be an entire agent. It takes in percepts and decides on actions. So obviously, the difference again will be back. What it will be having the sensors, it will be having the actuators, and in between there will be a performance element. Now, but this performance element will be actually the most important part between sensors and actuators. But this performance element will be dependent on these things like critics, then learning element, and then this one. Which one? This suggested exploratory action or the problem generator. So depending upon that, it will actually improve, and then the action will be taken. right? The learning element uses the feedback from critic on how the agent is doing and determine how the performance element should be modified to do a better in the future. Obviously सेंसर का एक इनपुट जा रहा है क्रिटिक्स को और क्रिटिक्स बताएगा कि कैसे एजेंट काम कर रहा है, whether agent is doing a good or not doing. If it is doing good, accordingly the action will be taken. If it is not going good, then it will be accordingly modified to do better in the future. That is the most important thing about learning. The design of learning element depends very much on the design of performance element. Obviously सारा जो खेल है वो एक्चुएटर्स और सेंसर्स के बीच में जो एलिमेंट है कॉल्ड एज परफॉर्मेंस एलिमेंट वहां पर है. सारे इंप्रूवमेंट्स वहीं पे जाएंगे और लास्टली वही एक्शन लेगा. When trying to design an agent that learns a certain capability, the first question is not how I am doing to get it to learn this, but what kind of performance element will my agent need to do this once it has learned now. क्या ना, सबसे बड़ी बात है कि ये जरूरी नहीं है कि how I am getting, how I want to get to learn this. But the most important thing is that what kind of performance element my agent needs to do at this in order to, it hasn't learned how. So how it is learning, that is the most important thing. Now, how you're learning, that is not the most important part. So critic says how the agent is performing, and if it is performing good, the performance element factor will be dependent on that. So the performance element will be improving. So this is the mechanism actually how it works out. है ना, कोई तो भी बताएगा ये काम कैसे कर रहा है और फिर काम अगर अच्छा हो रहा है तो बताओ वो काम अच्छा हो रहा है, नहीं हो रहा है तो फिर आगे आने वाले इसमें फ्यूचर में काम अच्छा करेंगे, उस हिसाब से आपका परफॉर्मेंस एलिमेंट मॉडिफाई होगा. दिस इज हाउ द थिंग इज अबाउट. सो देयर इज अ फीडबैक, है ना. Feedback always helps to improve the things. If you're giving good feedback in anyhow what you have understood in the subjects also, in teaching also, if somebody is teaching you like me, you should always give a feedback. What will happen, that feedback will go to me and it will always help me to improve, because somebody is saying that okay, my language is not good, somebody may say that the way of teaching is not good, somebody may say that the subjects is very tough, he's trying to deal with it. There are different kinds of feedback that comes back to me, and if the feedbacks comes, obviously my performance element will improve, and accordingly I will take the action. If somebody tomorrow, if you say that my feedback is very good, then I will keep and maintain that goodness in my result. But sometimes tomorrow, if you say that my performance is not good, then my performing element needs to modify in order to get a good action. That is whole mechanism works out to be. So given an agent design, learning mechanisms can be constructed to improve every part of the agent. So who is responsible in all these things? Obviously the learning element, है ना. लर्निंग एलिमेंट ही है सब कुछ, जो सीख रहा है, वो जो बता रहा है और उस सीखने के बाद फिर परफॉर्मेंस एलिमेंट को बता रहा है. तो मेनली दो ही एलिमेंट पे सब काम चलता है. क्रिटिक्स ये बताता है कि लर्निंग एलिमेंट काम कर रहा है या नहीं, उसमें इंप्रूवमेंट की जरूरत है या नहीं, और उस हिसाब से जो परफॉर्मेंस एलिमेंट है वो मॉडिफाई करेगा, इंप्रूवमेंट करेगा और फिर एक्चुएटर्स को वो एक्शन लेने के लिए देगा. सो दिस इज व्हाट द लर्निंग एजेंट एक्चुअली डज. Next point, the critics tell the learning element. The critics tell the learning element how well the agent is doing with respect to the fixed performance standard. Okay, अभी उस डायग्राम में आप देखोगे यहाँ पर, कहाँ गया वो, हाँ, यहाँ पर देखो एक परफॉर्मेंस स्टैंडर्ड है फिक्स्ड. तो क्रिटिक्स के पास पता है कि कैसे एक परफॉर्मेंस स्टैंडर्ड रखना है, यानी कि अगर वो परफॉर्मेंस उस हिसाब से नहीं हो रहा है लर्निंग एलिमेंट का, तो वो और सीखेगा, है ना. तो क्रिटिक्स के पास एक स्टैंडर्ड है, वो स्टैंडर्ड के हिसाब से लर्निंग एलिमेंट अगर सीख नहीं रहा है तो फिर वो परफॉर्मेंस इंप्रूव करने के लिए चांस है. सिमिलरली जैसे टीचर्स होते हैं, टीचर्स के पास एक स्टैंडर्ड होता है कि इस तरह से पढ़ाई करनी है, स्टूडेंट को वो बताते हैं कि दिस इज द वे यू हैव टू स्टडी. सो हु इज दैट? द टीचर इज लाइक क्रिटिक्स. So it keeps on saying that this is how you should, this is how you should. And if you start improving, obviously the performance in your result will be improving and the action will be taken accordingly. So this critics will be very important, right? So The critics tell the learning element how well the agent is doing with respect to fixed performance standard. The critic is necessary because the percepts themselves provide no indication of the agent success. Obviously जो सेंसस से जो आ रहा है, जो इनपुट लिया जा रहा है एनवायरनमेंट से, वो डेटा तो आपको कुछ देने वाला है ही नहीं. तो इसका मतलब क्या है कि परसेप्ट जो है, जो लेते हैं हम, परसेप्ट इज व्हाट, द सेंसिंग ऑफ द इनपुट फ्रॉम द एनवायरनमेंट बाय द सेंसर्स, दैट इज नथिंग बट परसेप्ट्स. वो तो कुछ इन्फॉर्मेशन, वो तो रॉ इन्फॉर्मेशन है, वो तो कुछ बताने वाला है नहीं. तो एक्चुअली क्रिटिक्स चाहिए आपको बताने के लिए. तो वो जो चीज बीच में आ रही है वो है आपका क्रिटिक्स. सो क्रिटिक्स जो है वो सेंसर्स से डेटा लेगा और बाद में वो उसके स्टैंडर्ड से मिलाएगा और फिर आगे भेजेगा कि कैसे होना चाहिए. We can explain with this an example. A chess program could receive a percept indicating that it has checkmated its opponent. ऐसा समझ के चलिए कि एक चेस प्रोग्राम है और इनपुट जो मिल रहा है उसको कि भाई सामने वाले ने उसको चेकमेट दे दिया है. बट इट नीड्स परफॉर्मेंस स्टैंडर्ड टू नो दैट दिस इज अ गुड थिंग. उसके पास कोई तो स्टैंडर्ड चाहिए ना. वो कैसे चेक करेगा कि सामने वाला चेकमेट दे रहा है? इसका मतलब उसके पास कोई तो भी नॉलेज चाहिए, तभी वो बोलेगा कि हाँ चेकमेट मिल रहा है मुझे अपोनेंट से. बराबर. सो बट इट नीड्स अ परफॉर्मेंस स्टैंडर्ड टू नो दैट दिस इज अ गुड थिंग. द परसेप्ट इटसेल्फ डज नॉट से नो. सो तो खुद तो चेकमेट आपको खुद तो बता नहीं रहा है अपोनेंट सामने वाला कि अभी तू चेकमेट होने वाला है. तो कोई तो भी नॉलेज ही आपको देगा कि ये आपको जज करेगा कि हाँ अब चेकमेट मिलने वाला है मुझे. राइट. सो द परसेप्ट इटसेल्फ डज नॉट से सो. सो इट इज इंपॉर्टेंट दैट द परफॉर्मेंस स्टैंडर्ड बी फिक्स्ड. तो ये पता करना बहुत जरूरी है कि कौन सी चालें हैं जो आपको चेकमेट के लिए रिस्पॉन्सिबल है, ये उस परफॉर्मेंस स्टैंडर्ड में होनी चाहिए. तभी आप जज कर पाएंगे. what you might be judging, that you are getting checkmate from the opponents. Is it okay? Now you're getting a very clear picture. So there is a sensor as environment, there is actuator. From sensor it is going to critics, from critics it is going to learning element, from learning element it is going to performance element, from learning element there is a generator, problem generator, and that will also go to the performance element. Now performance element will come to know how the performance is done, and accordingly it will give to the actuators for the actual action of implementation. So this is how the चक्र जो है अंदर घूम रहा है, जो काम हो रहा है वो फीडबैक बेस्ड है. फीडबैक इज ऑलवेज गुड. कंट्रोल सिस्टम्स में भी फीडबैक्स होते हैं, इसीलिए वो सिस्टम अच्छी तरह से काम करता है. राइट. The last component of the learning agent is the problem generator. Now we have seen each and every element. Now we have to see this is the element which is remaining there called as a problem generator. Now what does this problem generator do? It is responsible for suggesting actions that will lead to new and informative experiences. So problem generator ये बताएगा कि कौन सा action लेना चाहिए जिसके वजह से नया और informative experience मिले. बराबर. The point is that if the performance element had its way, it would keep doing the actions that are best given what it knows. अगर problem generator नहीं है और learning element से performance element की तरफ जा रहा है तो performance element based on the actions को लेता रहेगा. लेकिन कोई तो बीच में बताने वाला चाहिए ना कि ये ऐसा अगर डिसीजन लोगे तो ऐसा हो सकता है, ये ऐसा डिसीजन लोगे तो वैसा हो सकता है. तो वो कौन बता रहा है? प्रॉब्लम जनरेटर बता रहा है. The point is that if the performance element had its way, it would keep doing the actions that are best given what it knows. जो उसको पता है उस हिसाब से वो एक्शन लेता रहेगा. लेकिन सजेशन देने के लिए कोई अगर बीच में आए तो परफॉर्मेंस इंप्रूव हो सकती है. But if the agent is willing to explore a little and do some perhaps suboptimal actions in a short run, it might discover much better actions for a long run. तो अगर प्रॉब्लम जनरेटर बीच में आकर आपको सजेस्ट करता रहेगा कि इससे ये हो सकता है, उससे वो हो सकता है, तो ऑब्वियसली नए कुछ बेटर एक्शंस लॉन्ग रन के लिए काम में आ सकते हैं. तो प्रॉब्लम जनरेटर इज अगेन अ वेरी वेरी इंपॉर्टेंट रोल in this whole procedure. The problem generator's job is to suggest these exploratory actions. So ये वो actions बताते चलेगा जिसकी वजह से परफॉर्मेंस एलिमेंट को मदद मिलेगी कि वो कौन सा बेस्ट एक्शन ले according to all the studies that it will receive. To make the overall design more concrete, let us return to the automated taxi example. चलो Taxi example is the best example. Last time also we saw about the reactive and deliberative, and then goal driven, utility driven. All those things were explained with the help of a taxi example. So if you remember that taxi example, you can remember all these concepts, right? Now, कैसे check करें? The performance element consists of whatever collection of knowledge and procedure the taxi for selecting its driving action. Okay, so performance element consists of whatever collection of knowledge and procedures the taxi has for selecting its driving action. ड्राइवर के पास पूरी तरह से टैक्सी चलाने का नॉलेज है, जहां तक है. द टैक्सी गोज आउट ऑन अ रोड एंड ड्राइव्स यूजिंग द परफॉर्मेंस एलिमेंट. जैसे कि ड्राइवर के पास पूरी नॉलेज है, तो परफॉर्मेंस एलिमेंट की मदद से टैक्सी रोड पर ड्राइव करेगी. ओके. The critics observe the words and passes information along to the learning element. उसमें से क्रिटिक ऑब्जर्व कर रहा है कि भैया कैसे चला रहा है गाड़ी, अच्छी चला रहा है, नहीं चला रहा है, बहुत स्पीड में चला रहा है, रैश चला रहा है, और ये इंफॉर्मेशन वो लर्निंग एलिमेंट को दे रहा है. For example, after the taxi makes a quick left turn across 3 lanes of traffic, the critic observes the shocking language used by the other drivers. So obviously अचानक से उसने लेफ्ट में टर्न ले लिया, तो क्रिटिक ने ऑब्जर्व किया कि अरे ये तो कुछ अजीबोगरीब भी लेफ्ट टर्न ले लिया और ये अलग ही तरीके से गाड़ी चला रहा है, बड़ा मुश्किल है. So from this experience, the learning element is able to formulate a rule saying that this is a bad action. So according to the अंदर जो learning element है ड्राइवर के अंदर, हाँ उसको ये पता चलेगा कि भाई मेरे को क्रिटिक्स ने बताया है कि ये अच्छी तरह का एक्शन नहीं है, इससे तो गाड़ी एक्सीडेंट होने के चांसेस है, इट इज अ रैश ड्राइविंग. So accordingly, what is happening now, the learning element in the driver is suggesting to formulate some rule कि भाई ऐसा चलाने से ऐसा हो सकता है. And the performance element is modified by installation of a new rule. So उसके दिमाग में बैठ जाएगा, अरे यार ऐसा लेफ्ट टर्न लिया था मैंने, रैश में चलाया था, तो एक्सीडेंट होने के चांसेस है, तो अभी उसके दिमाग में नया रूल आ गया. The problem generator might identify certain areas of behavior in need of improvement. उसमें प्रॉब्लम जनरेटर सपोर्ट दे रहा है कि भाई तू ऐसा करेगा तो ऐसा हो सकता है, अगर तू ऐसा करेगा तो वैसा हो सकता है. So depending upon it, is giving the suggestions. So the problem generator might identify certain areas of behavior in need of improvement. तो भाई तू ऐसा बिहेव मत कर, ऐसा बिहेव करेगा तो ऐसा हो जाएगा. क्रिटिक्स ने बोला है लेकिन ये सजेशन भी दे रहा है इधर से. And it suggests experiments such as trying out the brakes on different road surfaces under different conditions. So लेफ्ट में टर्न मारने के बाद कौन सा ब्रेक लगाना है, कितनी स्पीड से ब्रेक लगाना है, कब लगाना है, स्पीड कितनी होनी चाहिए, ये सारे सजेशंस दे रहा है प्रॉब्लम जनरेटर. सो इस तरह से लर्न कर रहा है ड्राइवर, क्रिटिक्स बता रहा है क्या गलती हो रही है और प्रॉब्लम जनरेटर बता रहा है कि कैसे इंप्रूवमेंट हो सकती है. उस हिसाब से लर्निंग एलिमेंट अंदर रूल्स में चेंज कर परफॉर्मेंस एलिमेंट बाहर आ रहा है. सो द एक्शन एक्चुएटर से लिया जा रहा है कि टैक्सी को लेफ्ट या राइट में न लेते हुए सीधा चलो, या अच्छी तरह से चलो, या स्पीड इतनी रखो. दिस इज हाउ द लर्निंग एजेंट वर्क्स आउट टू बी. सो द बेस्ट एग्जाम्पल इज ऑफ टैक्सी ड्राइवर. इफ यू अंडरस्टैंड दैट एग्जाम्पल, you can understand all these agents. So here we finish the learning agent as well as unit number 1. So once again, just little bit of revision and recall what we have studied so that it will be understood by you. So this is what we have studied about deep learning, machine learning, artificial intelligence. So deep learning is a subset of an ML which makes computations of multi-layer neural network. Machine learning subset of an AI uses statistical method to enable the machines to improve with experience. AI enables machine to mimic like a human behavior. That is what the artificial intelligence, deep learning, and machine learning is about, right? Then we have also seen some of the definitions of artificial intelligence like by John McGrath, which says that the science and engineering of making intelligent machines, especially intelligent computer programs, are called as artificial intelligence. Some more examples we have taken is like AI, which is nothing but a field that studies the synthesis and analysis of computational agent that acts intelligently. Then we have also seen what is agent. It is something that acts in an environment. It does something that is called as the agents. Then there are few types of agents we have seen, like human agents, robotic agents, software agents. Then we judge an agent by its action. An agent acts intelligently when what it does is appropriate for its circumstances and goals, when it is flexible to changing environment and changing goals, it learns from the experience, and it makes appropriate choices given its perceptual and computational limitations. Then agent typically cannot absorb the state of world directly. It has only a finite memory and does not have unlimited time to act. So obviously the most important line is that we judge an agent by its action. An agent acts intelligently. Two more things that comes into the picture is, in human, the computations is carried out in a wetware, whereas in computers, it is carried out in hardware. Then the goals of artificial intelligence to create expert systems, to implement human intelligence in machines. And the central scientific goal of AI is to understand the principle that makes intelligent behavior possibly in a natural or artificial systems. So obviously artificial को बिल्कुल natural की तरह काम कराने का काम यानी कि central goal है of AI. And one more goal is that the central engineering goal of AI is to design and synthesis of a useful intelligent artifacts. We actually want to build agent that acts intelligently, and such agents are useful in many applications. Then these are the contributions to AI. Who contributes? Obviously the disciplines like computer science, biology, psychology, linguistics, mathematics, and engineering. The most and major thrust as far as human intelligence is concerned are reasoning, learning, and problem solving. The multiple areas or a single area can contribute to build an intelligent system. This is the program without AI and program with AI. So program without AI can answer specific questions, whereas programming with AI can answer generic questions. Modifications in program lead to change in structure without AI, whereas an AI program can observe new modifications. Then modification is not quick and easy, whereas in this case, it is quick and easy modification is possible. AI techniques. So AI technique is a manner to organize and use knowledge efficiently in such a way that it should be perceivable by the people who provide it. It should be modifiable or to correct the errors. It should be useful in many situations through it is incomplete or inaccurate. The AI techniques elevate the speed of execution of complex program it is equipped with. Scope of AI: education, chatbots, automated grading, healthcare, agriculture, transport, home, AI in cybersecurity, manufacturing sectors. Approaches of AI. There are mostly 5 approaches of AI. First is symbolic logic and symbolic reasoning. Second is the connections that are based on neurons of the brain. Third, evolutionary algorithm that test variations, Bayesian approximation, systems that learn analogy. These are the problems of AI: lack of technical knowledge, the price factor, data acquisition and storage, rare and expensive workforce, issue of responsibility, ethical challenges, lack of computation speed, legal challenges, AI myths and expectations, and difficulty of assessing vendors. Then we have the intelligent agent. So it is a computer system with autonomous action in some environment. Intelligent agent is simply an agent that is a component of a software or a hardware that it perceives and acts autonomously in open and dynamic environment, learning and cooperating with the other agent to offer a benefit to the user. So you can see there is an environment, sensors, feature extractions, inference engine where the learning model is implemented, then the actuators for the action. This is how the agent works out to be. It is also called as bot. Then the agent is anything that can be viewed as perceiving its environment through sensors and acting upon the environment through actuators. So you can see that it percepts through the sensors, and the agent will be giving through the actuators will be taking the actions on the environment. So agent is nothing but 2-3 types: a human agent that has ears, eyes and other organs for sensors, hands, legs, vocal tracts, and so on, the actuators. Robotic agent has infrared cameras and sensors, various motors for actuators. Software agents may be having file contents, network packets as sensory inputs, whereas screen writing files and sending network packets as the actuators. So the job of AI, where it comes to write down the agent program, which can be implemented the agent function that is useful for mapping the percepts to actions. So where this program will be written, it is in the actuators, it is in the architecture. So agent is nothing but the architecture plus AI program. Types. First is a reactive agent. So you can see there is a environment, there is sensors, actuators, there is a state of world, action, decision, and then the rule is made. So according to the rule, the reactive agent will work. Second, deliberative agent will be having sensors, actuators. Instead of rules, there will be goals. There will be internal state, evolution, and prediction. So this is the difference between deliberative agent and reactive agent. Here there is a domain knowledge. Here there is internal state, evolution, and then prediction. Then comes goal-driven agent. So it having sensors, actuators. In between sensors and actuators, there will be what the world is like now, and that is internal state. Then what will be looking, what will it look like when I do action A, and then according to the goal, it will take an action that should be taken. Utility driven, so everything is same as far as the goal driven is concerned. Only the difference is that the what is the world is like now, what it will be like if I do action A. Through that action, if I am happy or not, that is whether this state is good for not good for it or not, and then accordingly the what action I should do it now, and then the actuators will take the action. This is called as the utility driven. And then the last comes out to be a learning agent, where there will be environment, sensors, critics, where the performance standard is stored. Then there is a learning element, problem generator, and the performance element. All these will be having a feedback, and through feedback, the performance element will be suggested in order to select the best action that it can be done. So this is about the learning agent. So I hope this all thing you have got very nicely. So this is all from my side. Any questions, students? We have finished the unit 1. Any questions would you like to ask? Or should I take attendance?